Okay, I already have a video posted where we went over the first part. This is basically what your test is going to look like, this first part. But I do have a second part that must be completed when you hand it in with your test. And this just gives us more practice. It gives us an opportunity to get a little bit extra practice to get you ready for the Chapter 4 exam. So let's quickly go over this. Hopefully, you'll watch this. Like I said, I have the answers in Schoology, but I want to actually show where everything's coming from. So the nice thing about these first four problems on this paper is that they factored for us. And since they factored for us, it saves us some time and we should instantly be able to know where this graph crosses the x axis. So since I have a factor that's x plus 1, I know -1 is going to be an x-intercept. Okay, again, I don't need a calculator to know that, but if I would type this into my calculator, I would see the graph is crossing at -1, and it also has a repeat. Since it's being squared, it repeats at 3. And that's all the information I need to know to be able to do a quick little sketch. And so really, I'm only concerned about the x-intercepts and the end behavior. There's an odd number of zeros, x-intercepts, so that means the graph has to point in opposite directions. So on the left, it's going to point down. On the right, it's going to point up. It's since -1 is not a repeat, the graph's going to pass through -1. It's going to turn. It's going to come back down. It's going to hit 3 and then turn at 3 because 3 is a repeat. Okay, so that's again a quick little sketch. For here, we know the graph crosses at 0 and we have a repeat at -2. So I'm going to plot -2. I'm going to plot 0. We know that once again that the graph's going to point down on the left, point up on the right. It's going to pass through, or excuse me, it's going to change directions at -2, turn, and then pass through 0. Okay, so since it's a repeat at -2, that forces the graph to turn instead of passing through. Okay, again, on a test, you can double check on a calculator. Okay, so then the last two, we're going to see that this is an even number. Okay, so that if this would be in standard form, the largest exponent would be a 4. So that just tells me that graph points in the same direction. And since I don't see any negatives, it's going to point up. But I should know that there's a repeat at 0. It passes through -4 and 6. So I'm going to put a dot at -4. I'm going to put a dot at 0 and +6. And we know this. Okay. So again, we just need to kind of just show the general. Again, we're not going to use a calculator to get exact points. I know it passes through -4. It'll turn, it'll hit 0, but not pass through 0 because 0 is a repeat. It'll bounce back, it'll turn, and then go through 6. Okay, that's what I want to see. Here we have a repeat at 5, and we have a repeat at 7. So I'm going to put a dot at 5 and +7. And all we need to make sure that we do is when you look at this, you're going to end up having it turn, and everything has to be positive. Okay, you can't pass through this since 5 is repeated. It's going to come down, hit 5, go up somewhere, turn, bounce off of 7. So again, we have a little W for this. If you type this in a calculator, you will see no negative outcomes. Okay, so again, more practice on what we learned in section 4.8. Okay, this is something you definitely will see. This was on the practice test. This is where you're going to work backwards. You're going to be looking at a graph, and then what I want you to be able to do is write the rule. Okay, so on this, for this graph, it passes through 0. So I'm going to write 0 just one time, but it hits 4 and repeats. So 4 is a repeat. So we're supposed to identify the zeros for each function, use the zeros to write an equation in factored form and then in standard form. So these are my zeros. Well, here's what the factors look like. Okay, so that's factored form, and I'm just going to multiply. I like to multiply my binomials, and what we're going to end up getting is x squared. My outers and inners are each negative 4x. That adds up to a negative 8x, and then you're going to get a 16, a positive 16. So here's your final answer. This is where you can type this in the calculator to confirm that when you type this in the calculator, you're going to get a graph that looks just like this. So here's the final answer. It's cubic. When I distribute the x, I get x cubed minus 8x squared plus 16x. And there's your answer. Okay, this next one, we're going to end up with a quartic, a degree of 4, because the graph is pointing up in both directions, so I know it's an even number, and I have an even number of zeros. Okay, so we need to realize -3, -2, we have +2, and +3. Okay, so when I write my factors, I'm going to write x plus 3. Now I'm going to put the x minus 3 right away. So I'm going to take this +3. If 3 is a 0, which it is, then x minus 3 is a factor. And then I'm going to have an x plus 2 and an x minus 2. Okay, just makes it easier to multiply because I'm going to multiply these two things together. The good news is your outers and inners are going to cancel out. So you're left with just x squared minus 9. Okay, you still want to do your outers and inners, but they're opposites. Get a negative 3x and a positive 3x. Same thing happens here. X times x is x squared. Your outers and inners disappear, and you're left with minus 4. So then the last thing we need to do is just multiply these two things together. So it makes sense that our answer is going to be x to the 4th. X squared times x squared is x to the 4th. You're going to have a negative 4 x squared and a negative 9 x squared for a total of negative 13 x squared. Okay, and then finally a positive 36. Okay, so that's the rule for that particular graph. Okay, one more page. This is just going to give you more practice on dividing. So expect a problem like number 7 on your test. We have to use long division. You cannot use the box for this problem because there's a 3 in front of your x. So I'm going to put a 3x plus 4 on the outside. I have 15x squared plus 8x minus 12. So this is going to be super similar, very similar to what you're going to see in your test. It should take about this many steps. And remember, to get started, I'm only concerned about this 3x. I'm concerned about that first term into this term, okay? And it will divide evenly. 3 fits into 15 evenly 5 times. X fits into x squared x times. Okay, so I have a 5x up top. Now, we must multiply. What's up top must be multiplied by the two things on the outside. We're basically distributing. So 5x times 3x is 15x squared. Line it up. And then 5x times 4 is 20x. Draw your line. And now here's the part that people are still making mistakes with. You must change to its opposite. Okay, the 15x squares are gone. You're going to be left with negative 12x, and I'm going to bring down the minus 12. And I start this process over again. 3 fits into negative 12. It's going to be a negative 4. And the x, you don't have an x here because x and x, it cancels out. So you just have a negative 4 up top. I'm going to multiply negative 4 times each of the terms on the outside. So negative 4 times 3x is negative 12x. Negative 4 times 4 is negative 16. I draw my line. I change the signs to their opposite. And in this case, I get a remainder of 4. So I put my remainder over the divisor. And this is my quotient. Okay. So remember, you can have a remainder. So not every single, we got so used to doing those half boxes where we always ended up getting a remainder of 0. But in this case, with long division, you can have remainders. Now, a problem like number 8, I want you to get down, but you will not see a problem this difficult, even though it's not so difficult. But I just want you to be aware of how you could do a problem where you're dividing by x squared minus x plus 5. So again, show me this work. When you get started, we're only concerned with the first term. So I'm looking at this x squared. Okay, so this should be pretty easy since it's just a 1 in front. 1 fits in everything. 1 fits into 6 times. X squared fits in to x cubed x times. Okay, so you're just going to have a 6x up top. So x cubed divided by x squared, you're left with just an x. Okay, so now, just like before, we have to multiply this 6x times everything. So we must distribute to each of the 3 terms, and everything should line up. So we have 6x cubed minus 6x squared. X times x is x squared. And then you're going to have a 30x. Draw your line. I highly recommend using a pen or something so you can distinguish between what you turn to their opposite. So make sure everything gets turned to their opposite. I like having a different color to show me that I did that. This cancels out. This leaves you with a positive 3x squared and then a plus 3x. And I'm going to bring down the 13. And I'm going to start this process over again. So x squared into 3x squared is just a positive 3. So then I need to multiply everything by 3 on the outside. So it's going to be 3x squared minus 3x. And then 3 times 5 is 15. I draw my line. I change everything to its opposite. And I'm going to end up with, and now this is, again, something that you need to make sure you understand. Oh, wait a second. I made a mistake here. I'm going to fix it right now. When I add here, this is a minus 3x. Okay, sorry about that. Just seeing that now that I made a little mistake when I add. I just brought down the 30x. You need to add your columns. So 3x squared. This right here is going to end up being a negative 3x, which is somewhat nice because not only did my x squareds cancel out, so will my x's. So the negative 3x and the positive 3x cancel out, and I'm left with a remainder that's just a negative 2. So I'm going to write negative 2 over my divisor. Okay, so again, show me the work. You will not see a problem like that on your test. But what you will see, and this is why I want to end this with just giving you more practice. You're going to have 3 of these problems. So remember, there are 5 scenarios. We still have the posters up on the side. But what you need to realize is you're only going to see 3 of these on the test just to save some time. You should know how to do all 5 scenarios. But to get started, we always must get a remainder of 0. So whatever hint I give you, in this case, I tell you 3 is an answer. You were supposed to cross out this 0, so it's 120. You had to fix that. 1, negative 1, negative 26, 20, and 120. Like I said, we must get a 0 or you made a mistake. Always bring down that first number. Okay, make sure that first number gets written below your box. You multiply, you add, you multiply, you add, you get negative 40. When I multiply, I get negative 120, which I can feel good about because I get 0. So in this case, we are left with a cubic. X cubed plus 2x squared minus 20x minus 40. So this has to be the scenario where we factor by grouping. So I'm just going to split this down the middle. I'm going to factor out an x squared, which would leave an x plus 2 inside the parentheses. Okay, again, we're never able to change this problem. If you distribute, you're back to this previous step. So we must have an x plus 2, which means we have to factor out a negative 20. Okay, negative 20 times x is negative 20x. Negative 20 times 2 is negative 40. But it gives us this. It gives us x squared minus 20 as a factor and x plus 2 as a factor. So with the 3 that was given, I know negative 2 is a solution, and I should have 2 more. So again, that's very important that we have all of them. Whatever the degree is, that's how many solutions we should have. So when you go to solve this, you need to realize, so I'm taking x squared minus 20 equals 0. I'm going to add a 20 right away. And then I solve by taking the square root, which is 2 answers. And I would prefer that you clean it up. 20 is 4 times 5, which is 2 root 5. That's the perfect answers that you should have for that problem. Okay, so make sure you realize we have 4 answers. We have a 2 root 5, we have a negative 2 root 5, we have a negative 2, and we have the 3. Okay, so number 10 should be easy. Put a negative 5 on the outside, 1, 5, negative 25, negative 6, and negative 30. So this is the one where we're going to see lots of zeros. So bring down the 1, we multiply, we get a 0. We multiply, and make sure you realize 0 times anything is 0. When we multiply, we get a 25, but when we add, we get another 0. When we multiply, we get 0. And when we do negative 5 times negative 6, we get 30, and we get a 0. So this is the one, if you look at the poster, there's one where you see lots of zeros because you're going to solve a quartic equation. So remainder 0, constant x term, x squared, x cubed, x to the 4th. So there's 1x to the 4th, and then negative 5x squared, and then a minus 6. And this should be very easy to factor. So again, 2 sets of parentheses. We don't need the diamond. We don't need the AC method because you're locked in at x squared, okay? So ways of getting negative 6 to add up to a negative 5, it has to be a minus 6 and a positive 1, okay? So now we have 4 answers that we need, okay? 4 additional answers because they already gave us the negative 5. We should have 5 answers because the degree is 5. When you solve this, you add a 6, take the square root of 6, so just leave it as plus or minus root 6 as a decimal. When you set this equal to 0, you have to subtract a 1 and take the square root of negative 1, which is imaginary. It's simply plus or minus I. The square root of negative 1 is an I, okay? But they're solutions. I could take my calculator, take I to the 5th power, plus 5 times I to the 4th minus 5 times I cubed minus 25I squared minus 6 times I minus 30. Hit enter, it'll be a 0 because the solution, there is a solution, it just happens to be imaginary. Okay, 2 more, and then we're done. And then this one, I have a negative 2 on the outside, 1, negative 2, and 8. We know we have to get 0. I bring down the 1. I multiply. Add, then multiply. I'm trying to do this too quickly. And then I add. But I feel good that when I multiply, I get a negative 8. When I add, I get a 0. So we're left with x squared minus 3x plus 4. And we need to solve that. And unfortunately, it can't be factored. So this is a problem where you could try, okay, ways of getting 4 times 1, 2 times 2, but no matter how I arrange them, I can never get a negative 3. Okay, you say, well, Mr. Reibman, 4 times negative 1 or 4 plus negative 1, or excuse me, negative 4 plus 1 would be negative 3, but that wouldn't give you a positive 4 when you multiply. So it can't be factored. So we still have the quadratic formula, okay, which most of you are very good at. So pick out your A, B, and C. Quadratic formula says opposite of B plus or minus B squared. So if B is negative, put it in parentheses. Some of you are still forgetting to do that. Minus 4 times my A times my C all over 2 times A. So all I need is that number underneath the discriminant, or underneath the the radical called the discriminant, -3 squared. Notice I'm not doing square root. It's just -3 squared minus 4 times my A times my C. And I get -7. So -7, but I'm going to make it imaginary right away. So I need you to understand that anytime you have the square root of a negative, it's imaginary that I should go out front. Some of you are putting it with the number. The I goes in front of the radical, and then just make the negative a positive. Okay, so this counts as 2 answers. So the 2 answers that we just figured out plus the -2 that we started with. That's all 3. Okay, last one. This one's going to be pretty easy. Then we're done. I have a 10, a -7, a -4, and a 1. We know we have to get 0. Bring down the 10, multiply, add, multiply, add. So now I'm multiplying again, and I get my remainder of 0. So I have 10x squared plus 3x minus 1. This is the AC method. So all I need to do is figure out A times C, which is -10, need it to add up to a 3x. So ways of getting -10, 10 times 1 won't work, but a 5 and a 2 will work. The 5 needs to be positive, the 2 needs to be negative to solve that diamond problem. So now some of you do that, but then you say x plus 5, x minus 2. That's not the factors. We have to rewrite this so that it is a grouping problem. Okay, so 5x and a -2x is still 3x, so I didn't change the problem, but allows me to draw a line, factor out the GCF on this side. When I come over here, we must have a 2x plus 1, which means I have to factor out a -1. Okay, so the number on the outside would be a -1, 5x minus 1, and 2x plus 1 are my factors. And again, just do a quick little check. 5x times 2x, hey, there's the 10x squared. Outside is a 5x, inside is a 2x. Together, it agrees with a 3x. And -1 times 1 is -1. So we have our factors. It should take you 2 seconds to know you have to add a 1, divide by 5. Yes, you get a fraction, but that fraction of 1/5 is the answer. And then for this one, I subtract a 1, divide by 2, and I get -1/2. Okay? Remember, all these answers can be checked on a calculator. If you graph it, your answer should match up with x-intercepts. Okay, so just keep that in mind, that's another way of double checking your answers if you have time. So that took 23 minutes to complete. Thank you for watching. Should I give you an opportunity for bonus points on the test? Will anyone just scroll to the end of this video in hopes that I will say, hey, do this, and I will give you bonus points on the test? Let's see, what could we do? Let's have you put for summary at the on the last page of your test, since I made a mistake. Where did I make my mistake? I made my mistake on number 8. Okay, so I forgot to just simply add. I brought down this number since I made a mistake, and I apologize for making a mistake on number 8. Here's what you need to do. If I see number 8 circled in the bottom corner of your test, I will give you bonus points on your test. So that'll prove to me that you watched this video to the end. Okay, hopefully you will have your practice tests complete. Redo it if you need to. Redo the problems, talk yourself through all the problems, and you can't help but do well on our last test of the marking period 2. Take care. Now we're close to 25 minutes, but thank you for watching.